Welcome to video 4. In video 4 we're going to answer questions 7 and 8. So question 7 reads, using the table above, find the atomic mass of the elements. And this is a copper atom. And we have two isotopes of copper. So we have copper 63 and copper 65. And the relative abundance of copper 63 is 69.17%, and copper 63 has a mass in atomic mass units of 62.929. Then the other isotope of copper is copper 65 with an abundance of 30.83 and an atomic mass unit of 64.927. So we have to find the average mass of copper using the two isotopes and the relative abundance. So remember, we have to convert the percent into a decimal, so we're going to move it twice. Then we're going to multiply it with our mass. Then we're going to get two answers. These two answers we're going to add, and we're going to find our final answer, which will be our average atomic mass. So let's do 0.6917 times 62.929, add that to 0.3083 times 64.927. We get our answer, and that would be our average atomic mass. There is no need to divide by 2 because the relative abundance already gives us the percentage composition of the isotope sample if we have two different isotopes. Now let's do question 8. Question 8 is where hopefully a lot of you will get some help. Question 8 is asking 6 different examples of converting moles and grams. So let's get started. Question 8, part A, is asking how many grams are in 4.23 moles of calcium. And remember, I am rewriting my problem. I'm restating what the problem is giving me. So I have 4.23 moles of calcium. I don't know how much 1 mole of calcium weighs. So I'm going to look at my periodic table, and I'm going to find calcium. And calcium is right there. So I want, and I'm going to divide what I have. So I want to have grams, so I'm going to put grams on the top. I want to get rid of moles, so I'm going to put moles at the bottom. For every 1 mole of calcium, I will have 40.078 grams of calcium. That is what my periodic table says. It says that for every 40.078 grams, I will have 1 mole, and if I have 1 mole, I will have 40.078 grams of calcium. So then I would run these numbers, and my moles would cancel out, and I would be left with grams of calcium. Let's do B. B is asking how many moles are in 56.98 grams of aluminum. Well, I have grams now, so I want moles. So I'm going to put moles on the top, and I have grams. In every 1 mole of aluminum, I will have 26.982 grams. So I have 26.982 grams of aluminum, and I'll just put 56.98 times 1 divided by 26.982. My grams will cancel out, and I'll be left with moles of aluminum. Let's look at D. D reads, how many moles are in 3.450 times 10 to the 23 atoms of lead? So let's write that number down. 3.450 times 10 to the 23 atoms of lead. Well, I want to find moles. So I will put moles on top. Moles of lead. And here must be atoms of lead. I don't know how many atoms are in one mole, but my constant table does. It tells me that in 1 mole I have 6.02 times 10 to the 23rd particles. Particles could be formula units, it could be atoms, it could be molecules, anything really. It could be feathers if I was counting feathers. 6.02 times 10 to the 23rd. So then I would multiply 3.450 times 10 to the 23rd by 1, and then divide it by 6.02 times 10 to the 23rd. Atoms will cancel out, and I'll be left with moles of lead. Now here's the trick. They're both to the 23rd, so I could just cancel these out, because when I am dividing by exponents, I can subtract them. So 23 minus 23 would give me 0. So now I would just have to divide the 3.450 by the 6.02. And that would be something very close to half, a little bit more than half, really. Now let's look at F. F is a multi-step equation. F reads, how many grams are in 7.651 times 10 to the 23 atoms of silver? So I'm going to restate my problem. 7.651 times 10 to the 23rd atoms of silver. And I want to find grams. Now I cannot do this with one step. So I have a two-step problem. Well, I have atoms, so I'm going to write atoms here. And if I want to find grams, well then grams should be here. And if I know how many atoms are in 1 mole, I could put mole here. And if I know how much 1 mole weighs, I could put 1 mole here. Well, I can always look at my conversion table to tell me how many atoms are in 1 mole. So 6.02 times 10 to the 23rd. And I can look at my periodic table to tell me that silver weighs 107.868 grams per mole. So then my atoms cancel out, my moles cancel out, and I'm left with grams. Exactly what my question was asking for. So then I would multiply 7.651 times 10 to the 23rd by 1, then divide that by 6.02 times 10 to the 23rd. Then I could multiply that by 107.868 and divide that by 1. All right, I hope this was very helpful.